हेलो स्टूडेंट्स, वेलकम टू दिस लर्निंग। एक छोटा कॉन्सेप्ट बट बहुत ही महत्वपूर्ण कॉन्सेप्ट देने के लिए ये वीडियो तैयार कर रहा हूँ। दिस कॉन्सेप्ट इज़ वेरी इंपॉर्टेंट फॉर केमिकल बॉन्डिंग, सॉलिड स्टेट केमिस्ट्री, ऑर्गेनिक स्टीरियो केमिस्ट्री, कोऑर्डिनेशन कंपाउंड्स एंड मेनी सेगमेंट्स ऑफ केमिस्ट्री। चलो शुरू करते हैं। Now our question is how to prove that the tetrahedral angle is 109 degree 28 minutes। सबसे पहले हम ये तो समझ लेते हैं कि ये tetrahedral क्या होता है। So as we know, the geometry of methane molecule is tetrahedral. This is our methane molecule and it is the geometry of the molecule. This is tetrahedral. We know this tetrahedral angle is nothing but 109 degree and 28 minutes. Okay, and in the molecule, like say butane, this is the structure of butane molecule. Okay, it is the presentation of this molecule. I have written in this molecule in flying wedge projection. All the carbon atoms in this molecule are sp3 hybridized. So the geometry around all the carbon atoms are tetrahedral. This one is tetrahedral, this one is tetrahedral, this one is also tetrahedral, this one is also tetrahedral, right? And the geometrical shape like this is known as tetrahedral geometry. Look, one atom is there and if there are 4 atoms symmetrically arranged around this atom, the geometry is known as tetrahedron. This is the geometry. Say one atom is present at the center and 4 terminal atoms are there. So the geometry of around this atom is tetrahedral. Now question is, what is the difference between tetrahedron and tetrahedral? Look, tetrahedron. Tetrahedron. Look, tetrahedron is a noun form. The polygon having 4 surfaces are known as tetrahedron. Look at here in this geometry, if the 3 vertices are connected, it forms a face. It is a trigonal face. If these 3 vertices are joined, they form a triangular face. If these 3 vertices are joined, they form another triangular face. This is the 3rd triangular face and this is the 4th triangular face. So there are 4 triangular faces are present in this geometry. So this polygon is known as tetrahedron. This particular geometry is known as tetrahedron, right? And all the shapes having tetrahedron-like geometry are known as tetrahedral shape. So tetrahedral is the adjective form of tetrahedron, right? ये geometry को tetrahedron कहते हैं और टेट्राहेड्रॉन जैसा शेप को टेट्राहेड्रल कहते हैं, राइट? अब हम देखेंगे ये टेट्राहेड्रल ज्योमेट्री के अंदर ये एंगल कैसे बनते हैं, राइट? नाउ लुक, दिस इज अ वेरी इंपॉर्टेंट कॉन्सेप्ट. Look at here, this is the central atom of this tetrahedral geometry. Around this central atom the geometry is tetrahedral, right? So if this is your cubic structure. It is a cube, and if we place this tetrahedron into the cube, look at here, what will happen? This is the 2. Look, this is the face diagonal of the cube and this one is another face diagonal of the cube, and if we place this tetrahedral structure into the cube, what will happen? Look at here very carefully. Look, a cube has 8 corners. The alternate corners of the cubes are actually the 4 vertices of the tetrahedral, right? So this is very important. Look at here, these are 2 opposite corners. So these 2 are the face diagonal atom of this face, and these two are the face diagonal atom of the opposite face. So if these four atoms are connected, a tetrahedral geometry is formed. Okay, you can see this is very important idea. If the alternate corners of the cubes are connected, they form a tetrahedral geometry, right? So look at here, this is the tetrahedral geometry which is placed in a cube. Okay, and the corner points, the vertices of the cube, the vertices of the tetrahedron are designated by A, B, C and D, and O is the central atom of the tetrahedron. Okay, right? So now we have to find this angle. This is the tetrahedral angle. We have to find, look at here, this angle. We can see from any angle. This one is tetrahedral angle. This one is tetrahedral angle. This one is tetrahedral angle, and so on. So we have to find this tetrahedral angle, that is COD or COB or AOB, etc. So now look, how can we do this? Now firstly we can draw a perpendicular on this diagonal, on this face diagonal, that is AB. AB is the face diagonal. AB is the face diagonal. Now we can join these face diagonal atoms, right? Now if we draw a perpendicular on this face diagonal, okay, and this point say is P, okay. So the tetrahedral angle is AOB, and we can designate this angle, that is POB, this angle as theta. Okay, so 2 theta is the tetrahedral angle over there. Now we can calculate this angle from simple geometrical idea. Now firstly, let the edge length of the cube is A. Let the edge length of the cube, the edge length of the cube is, suppose A is the edge length of the cube. So this length, this one is A, or we can say this length, this one is of course A. Now we can draw this square face of the cube over here. Okay, this is the square face. I can draw here. The square face of the cube. This square face is drawn here. So this is your point A, this is your point B. So, and this edge length is A, and this edge length is A. So of course from a simple Pythagoras theorem we can write AB equal to, AB length equal to root under A square plus A square. It is nothing but A root 2. Okay, this is the length of this face diagonal. This is AB. Now we can draw this segment. Now we can draw this OAPB segment over there. So I have drawn this segment, this OAPB segment over there. So this is the point O. This is your A, this is point P, and this is point B. Okay, so here of course, here it is here of course OAP and OPB are two right angle triangles. So this angle is theta. So this theta is the half of the tetrahedral angle, है ना? and in this cubic geometry the O atom is present at the center of the cube. So OP is, this length is half of the edge length A. So we can write OP, this OP distance, this is half of edge length, half of edge length of the cube, half of edge length of the cube. So this OP equal to half into A. So OP equal to half into A, and again this PB or AP, this AP and PB are equal, and from this square face we found AB equal to A root 2. So we can write AP, this is equal to PB, this is equal to A root 2 by 2. This is A by root 2. Okay, and this OP equal to half into A. So we can write definitely from this right angle triangle, from the right angle triangle OPB, we can write tan theta equal to definitely perpendicular by base, perpendicular by base. Here the perpendicular is PB and here the base is OP. So from here we can write PB equal to A by root 2 and OP equal to half into A. This one is nothing equal to root 2, and we can find the actual value of root 2 is 1.414214. This is the actual value of root 2. So we can write theta equal to, therefore theta equal to tan inverse 1.414214, right? And this one give you theta equal to 54.7356 degree. Okay, so the value of theta is 54.7356 degree, right? So now we can write the tetrahedral angle, here the tetrahedral angle is AOB, that is tetrahedral angle is AOB. This one will be equal to 2 theta, right? This one equal to 2 into 54.7356. This one give us 109.4712 degree. And as we know, 1 degree is equal to 60 minutes. So 0.4712 degree, this one means almost equal to 28 minutes. Okay, this is actually 28.2 around, this is 28 minutes. So this one is nothing but 109. So this one actually 109 degree and 28 minutes. So this is our tetrahedral angle, 109 degree 28 minutes. So ये कैलकुलेशंस में इतना कुछ खास नहीं है, लेकिन ये वाला कॉन्सेप्ट इज वेरी इंपॉर्टेंट फॉर डिफरेंट सेगमेंट्स ऑफ केमिस्ट्री. So this is all about today's video. So that's it from this video. Keep learning, take care of yourself. We will meet in the next video. Bye bye from now.